alarms are incredibly important to operators, and that's one of the key things that SCADA provides. We can recall it over time, or you can recall it by checking for a specific microbe. So in this particular application, we've got 2 racks of PLCs. The sensor's going to come in to the transmitter and then out, and that goes back to our SCADA system.
Truly, what you guys are talking about right now, the DO probes, the ORP probes, and the pH probes, it really is the heartbeat of activated sludge and this process of denitrification and nitrification.
Operators spend so much time and effort creating high-quality effluent in a wastewater treatment plant, using things like the RO skid behind us. But what controls these things aside from the operator? Operators cannot be turning levers and knobs 24/7. Today we are at the city of Morro Bay with Grant Chase, here to guide us through their SCADA system and explain what SCADA even is. Thank you for coming today, or letting me come to you today to talk about SCADA.
Yeah, thanks, Sean. It's a pleasure to be here. Yeah, we're going to go through the facility from the HMI back to the sensor. Really, SCADA is something that every modern operator is going to interface. So for some people, it's a complete mystery on how these numbers get to the screen. So we're going to talk a bit about that today.
And I would argue that the operator of the future really needs to know not only how to function with SCADA and interact with it, but potentially 10 years from now, program and get into the PLCs and do some of this work, sense pull sensors, calibrate sensors, things like that. Would you agree with that?
Yeah, I mean, there's a certain set of subset of operators that already have the disposition for electronics, and it's just really finding the training avenues to have them be comfortable in that setting. But I definitely think that the operator of the future has to interface with technology, and that tech is giving us numbers that come from our physical plants. So how does it get there?
Absolutely. So if you're looking at getting into wastewater treatment as a career, or you're studying for an exam, or you're just trying to figure out how to talk to your programmer, this video is definitely for you. So Grant, are you ready to go to the first stop?
Let's get it.
All right, Grant, we are in the city of Morro Bay's control room, and we are seeing all these SCADA screens here, a lot of HMI going on. Can you first tell us the difference between what an HMI is versus SCADA itself?
Sure. So the HMI, which is human machine interface, is the screens that you interface with the control system. So if I need to check how a piece of equipment is running, I can look at the screen at the HMI, control it. I control it at the HMI level. SCADA is an acronym, of course, for Supervisory, Control, and Data Acquisition. It's more than just a screen. It's a system that allows us to visualize the plant, control the entire plant, collect the data from it, and then visualize that for process control or for compliance.
Excellent, great. And so we've got a couple different interfaces right here. The one on the right you actually made, which is really cool. You won an award for that, didn't you?
I did in 2025.
That's really incredible. And so is there anything you want to talk about with relation to SCADA before you click through some of these interfaces and show us what's up?
Well, the most important thing about SCADA really is to be comfortable enough to navigate through it. And that's something that every operator should hopefully be trained on, so you can control your facility and have situational awareness, what the equipment's doing at any given time. It's a great resource for operations, but you have to be competent in how to use it. So seek training and find resources, make SOPs on how to navigate through screens. Those are important things to know about SCADA systems from an operational point of view. And of course, if you break down the acronym, Supervisory, Control, and Data Acquisition, it's on our tests, right?
Yep.
And supervisory means I can see what's going on in the process. Control means I can control how the process is going directly, turning pumps on or off, or maybe just controlling set points. And then data acquisition is all of the sensors and run signals that are happening throughout the facility are being recorded and put into a historian so we can track what's going on over time. So a good philosophy for an HMI structure is no more than 3 clicks deep to get into a piece of equipment to control it. So if we look here, I'm in an overview page.
Okay, I'm going to zoom in the camera so that we can see what Grant's talking about.
Okay, great. So a good HMI design is no more than 3 clicks deep to control a piece of equipment from hopefully wherever you are. So if I can get to a main navigation page, it should show me the full flow of the plant. And in this case, we've got our core screens going into our fine screens, the treatment area where we've got our BNR and MBR, and then we are completely processed and now in the RO feed tanks. From there, it goes to the outfall area and is pumped out. So if I need to inspect something in the treatment area, I can click there. That's 1 click. And with just the 2nd click, I could be on this particular pump, changing the set point, turning it on or off. So as you can see, the SCADA systems provide us rich contextual knowledge of the plant, where sensors are in relation to the process. So here I'm looking at the DO in a basin and the mixed liquor suspended solids. These are real-time readings, and of course they're being housed in a historian, which we'll hop over to next.
Great, that's wonderful.
Another really important element of SCADA, of course, is alarms. Being able to be notified when a piece of equipment is malfunctioning or not in a normal state. So SCADA gives us those situational cues. You can see here we have a level transducer that is in a alarm state. And if I click on that, I can get more information about what is going on with that particular piece of equipment, why it's an alarm. And so alarms are incredibly important to operators, and that's one of the key things that SCADA provides.
Hey everybody, just interrupting the video real quick to promote a couple math classes I've got coming up in person. If you were going to be at Tri-State Seminar in August, this August in Las Vegas, I will be teaching 2 math classes. The first one in the morning on August 5th is Wastewater Math 101. Obviously that's going to be introductory math. And then the second one in the afternoon is Wastewater Math grades 3 through 5. So all that information is on the flyer on your screen right now. If you are planning to attend, I'd love to have you in my class. So check out more information on tristateseminar.com. And now back to the video.
Okay, so we were talking about historical data collected from the SCADA system. So in operations, we're going to use that for a number of things. One is troubleshooting, the other is process control. So we have some relationship with how the process is running, and we get used to certain curvatures in the graphs, in basins and tank levels, tank trends, sensor trends, and also for compliance. So I'm going to go to that same BNR treatment area on our historian, and you can see that we have graphs for pretty much every sensor that was there. If I go back to the DO that we were looking at on that particular basin, I can move around to different time ranges and different frequencies. So right now I'm looking at a 5-minute data interval, but I can roll back to 7 days and get a kind of pattern of operations for the DO. You'll see swings in it, and you'll be able to kind of hone in on anomalies. Like you can see here that zone 2 in basin 2 was really low on the 3rd for some reason in just that one moment. You can pull in and try and learn more about like why that might have occurred. Could have been normal, but these tools give us a lot of power on going back and figuring out what's happening with the process or what's going on. And of course, then we have all of the numbers that we need for compliance reporting.
Excellent. Now, somebody out there who's never seen this before, seen a chart on SCADA, might be intimidated by all the squiggle lines and all the colors. Can you isolate 1 or 2 lines at a time? Say, I only wanted to see influent flow right now. Is there a way to take some of these features off so it's less crowded?
Oh, sure. Yeah. If you just wanted the influent, we would go here. Excuse me, wrong influent. There we go. We go here, and if I just want to see the influent, then I have just the influent graph over the past 12 hours. So yeah, we have pretty much every metric that you want to see about the facility represented in this platform.
Very cool.
As well as the SCADA platform.
So you can customize whatever data you need in that moment or whatever time frame it happens to be.
Yep.
Great. Now,
That's right.
I saw an interesting thing on the last screen where it looked like microscopy on your Historian in the upper right-hand corner. Oh, it's not there anymore, so that's kind of...
It'll load. The way the code works is it'll actually live stream the camera if the guys are doing it right now.
Really?
Yeah, so that's what it's waiting for. It tries to live feed for 10 seconds, and then if there's no one on the camera taking slides at that time, then it'll just play the last 5 that were taken.
Oh, super cool. So this screen in the upper right-hand corner is your microscope. And what you were just explaining to me is that it live streams when people are actually on the microscope, so people can see what's going on. But there's a historical aspect to it as well. Could we explore that for the YouTube audience out there?
Yeah, sure. So we have a simple user interface that when the operators are running their microscope slides, they can press a button and it will record a video or a picture. You can preset like, hey, I want 30 seconds every time, and then you just hit the button and it will start recording. It automatically puts it in a timestamp, saves it in our database, and then we can recall it here. We can recall it over time, or you can recall it by checking for a specific microbe. So if I just wanted to look for the water bears here, I could go to the tardigrade and have it reload and play a nice water bear video.
Nice. That is super cool. And this is helpful for looking back at past process, the condition of the sludge in certain time frames where you're experiencing certain things. You can cross-reference the microbes that were present at that time, and it's also helpful for new operators to be able to understand what they're looking at. Is there another use for this that I might have missed?
Well, if you are capturing it in a very organized way, like what basin it came from and everything, you can develop a relationship with what microbes maybe frequent one part of the process more than others. And also, as you're taking these samples over time, you're creating a data model that can be ingested into like machine learning that can actually tell you all about the microbes in your plant and learn from your plant. So you're creating that data set every time you save a picture.
Interesting. So interesting.
Yeah.
Very cool. So is there anything else on Historian that we should know about?
Well, that ideally you have access to any number at any time that you want. The most important thing about a Historian is that it's organized in a way that the operators know how to use it. There's a lot of plants that have thousands of numbers they're producing, but the numbers just aren't available for operations staff. So that's one of the things that we definitely sets Morro Bay's operators' resources apart, is that they know how to use this interface in both water and wastewater, and if there's something that's going on, they can find it. They can find that anomaly and go back and have some more context to, like an alarm or a high wet well level at 5 a.m. You could deal with it in the moment and then come back and say, hey, what did happen? Oh, we were having high amperage at that pump, then the pump locked out, and it kind of paints a story of what's going on.
Excellent. Very cool. Okay, so we've talked about the interface for the operator and how they can look in the historical data, but in real-time data as well. What are they talking to? What is the controller that they are actually interfacing with, I should say?
Yeah, so where does this stuff come from? So there's a sensor out in the field, and that sensor terminates to I/O on a PLC. A PLC stands for Programmable Logic Controller, And the PLC is the interface between physical sensors and the digital infrastructure that runs a SCADA system. So the PLC will take the sensor reading and turn it into a digital signal, and it can also use it in a control strategy or the code that runs your plant. So there will be automation, that kicks pumps on and off, doses accordingly, and that's all going to be handled within a PLC. And a PLC really is a hardened computer that's purpose-built to just run and run and run and not fail. So even if we lose our HMI, the screens that we interface with, the PLCs most of the time are still running. It's a scary moment for operations when you kind of lose the visual on it. Yeah. But we're going to go out in the field and we're going to kind of visit where those PLCs live. They're always, most always, in a control cabinet somewhere on the facility. So we're going to go track down where this DO probe terminates.
All right, let's go.
Okay, this is a typical control panel. So inside of here is where all the sensors and all the run signals for the pumps and motors of the facility will terminate.
Look at all that. So, what are we looking at?
So up top, we've got our PLCs. So in this particular application, we've got 2 racks of PLCs. This is rack 1, and this is rack 2. Each rack has an I/O board that's attached to it and has slots. So we've got slot 0, 1, 2, 3, 4, 5, 6, and so on.
And what's I/O? Is that input output?
I/O is input output. In the PLC world, there's basically 2 types of signals. You're going to have analog signals, so that's going to be our transducers, run feedbacks, speed feedbacks, from pumps and motors, anything that's a new number that's changing up and down. And so that's going to be analog. We have 2 directions, analog in the SCADA system and out from the SCADA system, analog output. And then we have our discrete inputs and outputs. Those are on and off, like a switch. It's run or stop. The way this particular panel builder arranged this panel is a great way to organize your I/O. So all the analog inputs are coming in here, and we have wires from the PLC to the terminal blocks, and then the field side wires that are coming from the bottom and from all the devices then snake up and terminate here at the terminal blocks. And so it's organized the same way it is up top with your analog inputs, your analog outputs, discrete inputs, and discrete outputs. So this is pump states, if it's running or if it's not, and this is telling something to turn on, open, close. These are commands, external.
And are these like run by fuses, relays? What's going on?
Yeah, so there are some fuses in here for things that need protection on it. A relay might look like this. There's lots of different form factors for them, but this one's called an ice cube relay. So the relay is here, it's in the socket, and if you also notice, speaking of the relays, that there's wire color here. So the yellow wire is foreign voltage in this particular panel. So it's voltage that's outside. Even if I have this de-energized, that's still going to be energized, this yellow wire. And then blue over here is a positive 24 volt DC. Most modern panels are a low voltage, so we can work on them hot. Another really important and critical component to control systems is the communications backbone. So here the plant has a fiber optic system, the fiber optic ring all the way around. This is called a switch. The Ethernet cables come from our I/O into the switch and then are transmitted across the fiber optic ring here. And so, of course, no communications, no SCADA system.
Very cool.
Yeah.
Okay, so inputs, outputs. So output goes to the HMI, does it not?
No, the output goes to the field device.
Okay, so what's the input?
So the input would be if a like a motor state. or a transducer reading. So if you have a level transducer, that level transducer is going to be sending a signal that the PLC is taking as an input. It's taking that number in, and then SCADA or the code that controls the facility can use that number in the process.
Gotcha. Interesting.
Yeah.
So those PLCs up there at the top is what the interfaces that the operators use. That's what that interface is talking to. So that, and it interprets using code, like computer code.
Yep.
What we see. Is that correct?
Yeah, that's correct. So from here, everything is put into a digital signal and sent through the switch, right? It hits that communications backbone, and then your SCADA software, whether it be Wonderware or Ignition, is then going to take that packet from the PLC and have a connection with that PLC to retrieve all of the tags, is what we call each point here, all of the tags and their particular metrics from the system, so we can build HMIs.
Very cool. So we have seen the HMIs, we have seen the PLCs, we have seen Historian, but how does what information is coming into the PLC? Like, what's the next step?
Yeah.
Working backwards.
So if we're going back out to the facility, the next thing that we would go out to is a sensor. That's the actual like source of the data, the source of truth for that particular number. So we're going to go chase down a DO probe that we looked at on the SCADA system, we looked at on the Historian. That particular DO probe is going to be outputting a signal, and we're going to take that as an input to the PLC. And so that DO probe is going to be coming in over here on the analog input side. There are drawings that we can pull it up and find it, but we're going to go out there on the deck and track it down.
Let's go. Okay, so we're here at aeration, right, Grant? And this is a little bit more familiar to me than what we've been seeing so far. And we even have an operator here in the back hosing things down.
Yeah.
Say hi, Jimmy.
Yeah, that's Jimmy.
Very cool. So what are we doing here? Is this a DO probe, you said?
Yeah, so this is DO probe. This is a Hawk DO probe. So what I'm looking at right now is what we refer to as the transmitter. So the transmitter is not the sensor itself. It's actually what's transmitting the signal from the sensor. Some sensors have integrated transmission, so it just comes right off the transducer and then connects to the PLC. But here, in the most Hawk setups, the sensor's going to come in to the transmitter and then out, and that goes back to our SCADA system. So if you remember, we were looking at Basin 2, Zone 2, so we can see that on the transmitter, and we're reading a 2.31 milligrams per liter. So that number right there is being pushed over to the PLC that we were just at via a 4 to 20 signal. And then the SCADA system is scaling that current that's flowing through the wire back to that 2.3. And then we historize it. We can view it on the HMI. We can also take it in and out of service because that number is related to high and low DO alarms as well.
Excellent. So Grant, you mentioned 4 to 20 milliamp signal. What exactly does that mean?
A 4 to 20 milliamp signal is a type of signal that uses current and resistance to measure and share basically a number from one device to another. So this device is going to have a resistance in it that when electricity is passing through it, it will increase or decrease that resistance. And then on the other side, a PLC is interpreting what that resistance level is and turning it back into a number. So it's not a digital signal. It's actually the flow of electricity through the conductor. It's being restricted or opened. So it would be like in the water world, it would be like interpreting what's happening with a flow meter, like how much volume's coming through into a number that you're reading from one side to another. Someone's got a hose and they're turning it up and you're watching that meter spin faster or slower or even kinking that hose, right? And that's kind of how a 4 to 20 signal works.
And 4 being, let's say, just anecdotally, 4 would be 0 parts per million, and a 20 would be a 7 parts per million, right?
Yes.
So long as you're scaled for that.
That's right. So 4 milliamps and would be 0, and 20 milliamps would be 7, and then it would interpret in between. So you have that 16 milliamp span. And a lot of people might say, hey, why is it 4 to 20 and not just 0 to 20? Because it's kind of like that riddle of why are manholes round?
Right.
So they don't fall in, right?
Yeah.
Well, this is so you know if there's power flowing through that line. If it's 0 milliamps and that's your 0, then you don't really know if that wire is hooked up or not.
Yeah.
But now if you see a 0, it's a tall tale sign that you've got a broken conductor not connected.
One of my favorite stories to tell about 4 to 20 milliamp is when I lost my pH sensor in aeration. I got a high pH alarm, and I logged on, and my pH was 14.9, and I immediately knew the sensor was dead because there's no such thing as a 14.9 pH.
Yeah.
And it's scaled out to 20
for
milliamps, and it just died.
For sure.
So.
And 4 to 20 milliamp is everywhere because it's a very robust signal, and it can travel over huge distances without degrading. So
awesome.
It's a lot.
Anything else to talk about up here?
We talked about the transmitter. So the sensor here is actually down in the basin because it's a DO probe. So one of the things that Jimmy was doing up here is cleaning up the basin, but they do a lot of maintenance on the probes. So one of the things that's super important is that you get reliable numbers in your SCADA system, and you can't just rely on SCADA itself. There's tons of sensor maintenance that needs to happen. Probes need to be cleaned and sometimes calibrated at regular intervals to stay true. And so that's a really important thing, is that the numbers that we get on SCADA are only as good as our sensor and probe maintenance.
Okay, so as we're out here talking with Grant, Jimmy came by and just said some of the best operational feedback regarding SCADA. And so I said, Jimmy, please, no pressure, but please be in the video. So tell us out there in YouTube world what you just said to me and Grant.
Yeah, so prior to being put on camera, I was like, this is great. I'm glad you're doing this because truly what you guys are talking about right now, the DO probes, the ORP probes, and the pH probes, it really is the heartbeat of activated sludge and this process of denitrification and nitrification. These probes talk directly to SCADA via 4020 or millivolt signal. They tell the plant what it needs as far as more air, less air, more pH. To keep the pH balanced, we need alkalinity in the denitrification. Without these components, and with us being able to see it at all times, you don't have denitrification, and you won't have nitrification, and you're not going to process your wastewater very well.
You're going to blow your permit, and
Yeah.
so it really is a testament to have an operator walk by and tell that to us, because that's something I see on a daily basis is the feedback loop, the blowers ramping up and down because I want 2 milligrams a liter in aeration right now, or I need negative 50 millivolts in my ORP and an oxic, and I need to have that feedback so I know, and like you just said, Grant, it needs to be correct. So, correct information. So I know, do I need to lower dissolved oxygen? Do I need to lower return? Like, what's going on? Why is my ORP drifting higher or lower, right?
Correct, yeah. And especially now that, hey, for those of you guys, we're getting into summertime, temperatures are rising, so your conveyance system may or may not be sending you your BOD that you want. And so at the beginning of this process, that's all telling you what is the oxygen reduction potential right from the get-go. So with his help of SCADA and the dashboards he's created, we can see it on our iPads, we can see it in the lab, we can see it in admin, we know exactly what's happening at all times.
Excellent, Jimmy. Thank you so much for giving us that feedback.
You bet, dude. You bet. I'm glad to be here.
Grant, thank you so much for taking us through all of the information today and welcoming us into this plant that's really quite sophisticated. How old is this plant anyway?
It was brought online October 2023.
Awesome. Thank you, Grant. Thank you, City of Morro Bay, for inviting the wastewater enthusiasts into your plant and helping the people out in YouTube land. Do you have anything else to say before we sign off?
SCADA is your friend.
SCADA is your friend. You heard it here first, folks. Catch you all in the next one.